Examples. 1. Sketch f of x is equal to cot x and negative 2 pi less or equal to x less or equal to 2 pi. So he said that for cot and tan, they share the same properties. And so the period of this graph is 2 pi over 1, which is equal to pi. And the scale is pi over 2. Horizontal shift is 0. So we'll have our sketch here. So from 0, we'll go to pi over 2. We'll go to pi, then 3 pi over 2. We end at 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And then if you try f of 0, that is equal to, hello.
Sir, I have a question.
Let's ask.
Why is scale divided? Why are we dividing scale by 2? Is it not supposed to be dividing scale by 4?
No, we said for tan and cot, we divide by 2 and not by 4.
Or only these two?
Only these two.
All right.
Yes.
So sorry, this is when I've joined. Is this when you started?
Yes, that's when I started. You haven't missed anything.
All right, thank you, sir.
Okay. Okay. So cot 0 is, this is the same as cos 0 over sine 0. So it is 1 over 0 undefined. So we put the asymptote line here. Linda. Then f of 90, we get cot 90. This is.
Yes, sir. I was checked out because of network, sir. Sir,
Hello.
you can.
Yes.
Sorry, sir. I want to ask this part of the positive x-axis. Yesterday, I wasn't clear. How are you getting this 3 pi over 2 pi, 2 pi, pi over 2? How are you getting this?
So we are adding to the first shift. So here we said the first shift. The first shift is 0. So we add the first shift, we add the scale. So any number we get, we keep adding the scale. So that's the spacing between the x values.
Okay.
Yes.
All right.
All right. So cos 90 over sine 90 is 0. Because cos 90 is 0, sine 90 is 1. So we have an intercept here. Again, at 180, undefined. At 270, an intercept. And here it's undefined. So here it's an intercept, undefined. An intercept, undefined. Now for court, the orientation of court is of this nature. This is the court orientation. There is nothing much on court and done. So if I go back and add, so if this question had a +1, if the question was 1 plus cot x, the difference would be that when you get, if the question was like that, then you just remove the 0 here. Anyway, let me demonstrate it nice. Not here. Right, I'll lose most of you. So this is for cot x. I can move to another example.
No, sir, wait. What is the difference between in the diagram? Oh, it's the sides, right?
It's there? You haven't
Is
asked the question.
Is it the sides of those like for tongue it was facing the other way. It was increasing. And this one is like going down.
Yeah, right.
Oh, okay.
Second, for tan, the zeros, the lines of these red lines were not on pi and 0, they were on pi over 2. 3 pi over 2. The zeros of cot are the zeros of cos. The zeros of tan are the zeros of sine.
At the zeros what?
The zeros of tan are the zeros of sine. And the zeros of cot are the zeros of cos.
Oh, okay.
Another one, example 2. We are sketching exactly. That was the first page. We are now on the second page. We are sketching f of x. Is that a question?
No, I'm just kind of asking for the previous board. So just edit like for a minute.
So why are we putting the red lines? The red lines are put here to indicate that the function is undefined on those points. And we call them the asymptotes. Yes?
Sir, like on this one, we've used the interval given. So this one will not be given the vertical shift which to use. Like for the previous, we are using the vertical shifts. We add on until we find the everything like that. Now why this one we use the interval?
We are all using the interval in all questions.
So for example,
Mhm.
like for the work we did yesterday, like for example, for sign, they've given us the interval is from 0 to 360.
Mhm.
And then the vertical shift, we find it to be 90. So meaning
The first shift.
The first shift we found to be 90. So meaning even we have to find for 0, have to include it, we find.
No, for our case today, the first shift is 0. So we treat it like we did for 90. Have you noticed that? So what we are doing on sign.
I've noticed we've used 0 because 0 is included there on the interval. Yes. So even if maybe we want to sketch for sign and the interval they've given us from 0 to 360, and then the first shift we found to be 90. We found it to be 90. So is it that we have to even find for 0?
Yes.
Oh, okay. That was. Thank you, sir.
So what question was that one? That you find for 0 what?
No, she was saying if the interval is from 0 to 360 and your shift is 90, do you have to go back to 0? So saying you have to go back to cover up the interval.
Oh, okay. Thank you.
So we sketch f of x is equal to 1 minus 2 cot x minus pi over 2. So to avoid calculating why are we used cos 90 over 90? Pi over 2 is 90. So it's the same. Magnetic drift. Okay. So for this one, for cot and tan, these are not like sine and cosec, where sine and cosec and sec, where we have to calculate all the angles and the angles will come out nicely. These angles don't come out nicely. So we just calculate for 2, that is the asymptote line and the intercept for x. The other parts we don't calculate. What we do is, if there are any shifts, we work on the shifts from the work from the start. So the period as agreed pi. So here we'll sketch from the same interval. So the period is pi over 1, giving us pi. The scale is pi over 2. The first shift, we notice that here it is x is equal to pi over 2. Okay. And then the vertical shift is 1. The amplitude is the modulus of -2, which is equal to 2. So then how do we sketch our function? So come here.
Sir.
Hello.
Sir. Are we always given the period, the scale, the first shift, and what? Or maybe we have to find them.
We have to find them. So we're finding them here.
How do you find
them?
Yes, but I'm lost. How do you find them?
What's the period? The period is for tan and cot. for tan and cot, the period is 180 over B. The amplitude is the modulus of A. The vertical shift is D. And the phase shift is Bx plus C is equal to 0. So for X. And the scale is a period over 2. Don't forget. So our first shift is pi over 2. So we start from pi over 2. We add pi over 2. We'll find ourselves at pi. We add pi over 2. We'll bat 3 pi over 2. We add pi over 2. We'll bat 2 pi. We've reached the interval. Now we should go back to the left. We subtract from pi over 2. We subtract pi over 2. We get 0 minus pi over 2 minus pi over 2 minus pi over 2 minus pi over 2 until we cover the whole interval. Then we substitute. So let's start from 0. What is f of 0? F of 0 is 1 minus 2 cot 1 minus 2 cot 0 minus pi over 2. That is 1 minus 2 cos negative pi over 2 over sine negative pi over 2. So here we get 1 minus 0. So we have 1. Now because cos 90 is 0. So whatever sine 90 is in the denominator there, we know we're just talking about 0. So we get 1. So we'll be at 1. That's where the
So what
0
about
is indicated. That's where the 0 is indicated. Oh, I was doing 0. What about?
So what about the negative inside the pi over 2?
So for
Like
cos,
for which one? For cos it would be like that, but for sine.
so cos is even, is it?
Mm.
So it will choose the negative and remain 90. Now cos 90 is 0. So sine negative 90, we know it's not 0. But because we have a 0 in the numerator, we don't worry about the sign.
Oh.
0 doesn't care about the sign, is it? So when we get a 1 as our intercept, we quickly draw dotted line to realize that what we are having is a vertical shift. So that the next one now, even if we don't calculate, we know the next one will be an asymptote. This guy here. And the next one will be this guy here. An intercept. And the next one, an intercept. Then we can sketch.
Sir.
You know?
I don't know if the question is clear.
Yeah, I really did it.
Okay, I'm saying like comparing to what we were doing yesterday, we were substituting all the values in the x axis. Now, like here, we are just using one value, like there. We have just used one value, then we have plotted the graph. Now, how about these other values?
So we have put it on those other values, is it? So if you remember yesterday, I mentioned that the more you do these graphs, the more you get to understand the pattern. So once you just calculate 1 or 2 points, you're able to fix up all the other points. So for tan and cot, we're only interested in 2 values. We know that these numbers here will be alternating. So if you first that, if you calculate the first number and you get an intercept, or you get undefined, you know the next number will be an intercept. The next one, undefined. The other one, an intercept. That's why with a scale, we divide by 2. They alternate. So if we try to calculate 490, let's calculate 490 and see what we'll get. We'll have 1 minus 2 cot 90 minus 90. This is going to be 1 minus 2 cot 0. But cot 0 is undefined. So we have 1 minus 2 undefined, which is equal to undefined. So that's why at 90 there is an asymptote. The next one, it will be defined and it will be 0. The other one, an asymptote, just like that.
All right, sir.
So this what is this? The cot, it doesn't have downward values, right? Like when, like the way we would have downward things, like it only has upward things. Yes, like it doesn't have values below, like 2 values for it to be supported. It only has, like the way we've said, 1, right?
We just get a pivot and then concentrate less. So it is about the other pieces. So this one has got, look, we have this vertical shift. Look, we have a vertical shift.
Yeah, so
Hello?
Okay, my question was like this. Why is it this one doesn't have much values? It only has one thing. Like it only has 1 point of the vertical shift. Like the shift won't even go downwards. Like for sine and cos, when we have a vertical shift, it will shift like that, even downwards on the negative side.
So the families are different. So the cosine and sine family, that family is different from the tan and cos family and cot. The tan and cot, if you look at the shape of their graph, this shape does not necessarily require so many points to be known. Okay, because it's blowing to infinite and negative infinite. But the other one for sine and cosine, it was just between some numbers. It wasn't blowing up or down. So it was bounded down, bounded up. So because of that, we could know where it is turning from down, where it is turning from up. Now this one, we will only have to know where it starts going down, where it becomes free going up, okay? So I deliberately skip that point so that I bring it now here, where we have a shift. So after I have a shift of 1 vertically, and the amplitude is 2, so we know at 3, so at 3 and at -1, that is where, when we are graphing now, when COT is negative, your graph does not orient in the same way the positive one orient. When COT is negative, the graph will orient as if it is tan. So its orientation will be of this nature. So it will be free when you reach when you reach +3, it will come to start turning, coming to the intercept, crosses there, until when you reach -1, it will blow down again. So you come all the way from there. When you reach 3, you turn to the middle point. You move, you reach 1, you turn to the down. The same thing would happen here. So from here, you would move until you reach 1, the graph will become free going down. The same story here. And the same story here. So meaning that when sketching this one, we needed to state our amplitude was equal to 1 and put 1 to help us know that now we curve in, now we curve out for these graphs. Now take note that for the negative cos, we note 1, the negative cos, the negative COT is oriented in the tan orientation. And the negative tan is oriented in the COT orientation. So you take note of that. So when it is negative tan, negative COT, it will look as though it is the other function.
Sir,
Yes.
I don't understand why you're using 3.
Oh, we're using 3. Oh yeah. Oh, we're using 3.
Yeah.
Oh yeah. So we're using 3 because the amplitude is 2 and we have a shift 1. So we first indicate the shift 1. The amplitude is the stretch number. How far do you stretch up? How far do you stretch down? So from the vertical shift, how far do you stretch on top? Now we're saying it is 2. How far down? It is 2. So 1 we add 2, we get 3. 1 we subtract 2, we get -1. We get 1. So on the shift, we add the shift, we add the
Here on the first one, F0, is it on the graph? Is it white? I can't really see.
1.
Sir, on that point where you have added, that's the point where, like upwards, for the positive values, that's supposed to 10 to start curving, right?
Yes.
On the and on the down part, what is it supposed to do? It's just where just like that.
Down part also it keeps going down.
Okay, all right.
So you don't show it as 2, but by adding on the 1 and subtracting 7. That's how you show the amplitude. So we have done one on tan, one on court. So zoom